All right, guys, we're just about at the end of chapter 6, and we also dipped into chapter 7 just a little bit. So we will be hitting chapter 7 in about 5 minutes, especially since I already lectured on this. Overloading functions. Overloading functions is when you have the same function name with more than one function parameter list. So that would look something like this. I'm going to define two different structures. And I ought to be making, I'll type this, but a structure is something that's got more than one data element. I guess it could only have one data element. Like, for example, I could make a structure called a square, and all it does is it has one value, which is a side length. And then I could write another structure that was a rectangle, and it had two values tucked inside it. It had a height and it had a width. So down in main, I could create one of each of those. Square s dot side is equal to 10, and then I might want to call a function that'll print that square. I haven't written that function yet. And then let's create a rectangle. Rectangle r dot height is equal to 20, r dot width is equal to 10, and then print r. Okay, so you can see that a structure contains or can contain multiple pieces of data. It can contain multiple variables, right? This one variable here, r, has two components. It's got a height and a width. And we can pass that to a function. What if I wanted to make this print function so that it was capable of printing both squares and rectangles, like I have shown here? Well, those are two different data types. I'm going to have to use overloading to get that to work. Now, it doesn't need to return a value, so I'm just going to declare it as void. But I'm going to write two different versions of it. One that takes a square, and then another one that takes a rectangle. And so C out, whatever, right? Square side equals, right, s dot side. And the other one's going to print out something similar. C out, rectangle, height equals, and so on, right? R dot height, comma, width equals, arrow, arrow, r dot width. Like that. So we can call the same function on the different data types. We could write another version that just accepted a string, and another version that printed an int, and another version that printed a double, for whatever purposes. I'm going to add one more. Print, and it takes an int, and all it does is C out, arrow, arrow, int value equals, arrow, arrow, I, arrow, arrow, India. So I could print any of those three things out. I could print a square, I can print a rectangle, or I can just print a number, right? There, like that. And it'll print out that that's an integer. That's the idea of overloading. Methods with the same name but different parameter lists. Use overloading to make your code easier to read, right? I don't want to have to write a function called print rectangle, and another one called print square, and another one called print int, and then 37 other print functions. If I can just reuse the same function name, and it's smart enough to know which one to call based on the argument that's passed to it. Right, so when the compiler linking all this together, stitching all this together, it looks to see what function needs to be hooked up. And so it looks at the type. Oh, I need a function called print that accepts a string. and it looks. Do you have a function called print that accepts a string? Well, it's not a string, I'm sorry. A function that is named print but accepts a square. It looks, it finds one, great. It stitches it together, and so when the code runs, then we print a square. It's going to run this little bit of code. The next one's trying to print out something of type rectangle. The compiler checks, do you have a function named print that accepts a rectangle? Yeah, it sure does. Okay, so that's overloading. Maybe we'll throw that in when we actually start writing some code, but I think that's about enough of that. And then there's one more slide on here called the exit function. Oh, well, I guess there's more than one slide, but pretty close to the end. The exit function just kills the program. Return causes it to exit the function that you're in. And if you're inside main, then calling return does kill the program. But exit will kill it from any area in your program. Terminates the execution of a program. Returns an integer value so that the operating system can check to see what it returned, and you can use that like as an error code. Usually use it for abnormal termination of the program. And it does require a header file. So the C standard library defines two constants, exit success and exit failure. So if we wanted to, instead of a return statement down at the bottom, we could do exit parentheses exit success. And then if we ran into an error, we could return that. That'd be all fancy and neat. And so if we were writing code that was going to be called, running an automated process, and we needed to find out whether the program succeeded or not, then we could return those values or other values, and then have the calling script check the return value from the code. Stubs and drivers. A stub is a dummy function used in place of an actual function. All it needs to do is display a message indicating it was called. And then the driver is a function that tests another function by calling it. Okay, so say I was writing some code, and I knew that I was going to write a function that calculated the inverse of a fraction. But I didn't want to actually take the time to write that function. But I could piece it out in my mind. Well, it's going to take a double. It's going to be double. I'm going to call it inverse. It's going to take two ints, int x, int y, and it's going to return y divided by x. But I don't know what it's going to do. I'm not smart enough to figure that out, so I'm just going to see out a message. Inverse called. If I wanted to be fancy, I could print out the parameters, right? See out x param equals, right? And do the same thing for y. And then I think, okay, now that I've got that inverse, I'm going to write it out to a file. I'm not ready to actually figure out how to write to a file, but I know that I'm going to come back in and fill it in. So bool write to file, and I better take a file name as a string, and a double as my value to write out to a file. Alrighty. And then I could see out the same kind of stuff, right? Write to file called, right? And then I could write out its parameters. And so down in main, I could call one function, right? I could get the data in, cn into x, and then I could say, double y is equal to the inverse of 1 over x, and then I want to save that to a file, write to file, output.txt, comma y, right? The program will run. Is it going to do anything useful? No, it's not. All it's going to do is print inverse called, and it's going to print out those parameters, and then it's going to print write to file called. But you can create the skeleton of it. That's called stubs, or stubbing out the program, right? Later on, we come and we flesh out the skeleton. We make the inverse function do what it's really supposed to do. And we make the write to file function do what it's really supposed to do. Now, a driver, I don't know why they use this particular definition here, but in this case, they call it, this book means that a driver is a test function. It tests your code here. I need to figure out whether the inverse function works or not. Oh, by the way, this code would not compile. What's wrong with this code and this code? Besides the fact that I may have made some typos, there's a serious problem with that. If I copied and pasted this into a .cpp file, it flat out would not compile.
You don't have a return statement.
Exactly. I don't have a return statement, but I have a return type. So I guess I could just return a -1, you know, and I could return a false, you know, whatever. There. Okay. So to test my inverse function, right, double test is equal to inverse of 1/2. So that ought to be 0.5. If test is equal to, you know, 0.5, then, you know, inverse works. Else, CIT, inverse fails. Like that. So you can write a test suite. You can write a whole bunch of test functions, or test code, drivers that test all the functions in your code, or a good number of them. And then whenever you run a test suite on it, you can kind of validate that your code is in a good state, that you haven't broken something seriously. Right? Like what if I get the definition of inverse wrong, or somebody else comes in and thinks that they know what inverse does and they change the code for it. And so that when you call inverse of 1/2, it no longer returns 0.5. When that I run my test functions, it would say that inverse failed. I would know there was a problem before I shipped it out to the customer. So that's a function that tests another function by calling it. What I should do is I should break this out into its own function. I can make it return a bool whether it works or not, right? So bool test inverse. And it's going to take an X and a Y, you know, or something like that, or maybe it doesn't, right? And so it's just going to call inverse several times in a row. Make sure that it works. We might call it with 1/2, we might call it with 1/1, make sure that works, and that sort of thing. And if it ever fails, it's going to return a false. Otherwise, it's going to return a true. So forgive me for fleshing this code out just a little bit so that we have a good example of it. But if it fails there, it's going to return a false. And now I'm going to test it once more. I'm going to test it with 1/1, because 1/1 inverted is still 1. So I could do it again. Test is equal to inverse of 1/1, and I could test to see whether that worked, right? And down here in my code, I could call that function, you know, Boolean OK is equal to test inverse. And I could check to see whether that worked or not, whether that function works or not. And if the inverse function gets changed so that the test no longer works, then we find out right away. That's the idea of a driver according to this book. You can write, you know, a lot of test code. And some programming paradigms, you write the test before you actually go and you write the code, right? You write a whole bunch of tests. The tests are all going to fail. And then you create a whole bunch of stubs for the drivers to test. And then you start going in and fleshing out the code so that they actually do what they're supposed to do. And the last time you run it, it works. All the tests succeed. Well, that's obviously not really the last time, right? But you hit a milestone when all the tests succeed, and you keep developing, you keep adding new test functions and so on. That's called test-driven development, or at least that's one definition of it. There are utilities that help you create those test suites. I don't know where they are in Visual Studio, but I know they're there. All right. So the stub is a dummy function. Usually displays a message indicating it was called, may display its parameters, then a driver is a function that tests another function. Arguments are passed in and return values are tested. Alrighty, that's about enough of that. Let's go to the next chapter. Which I believe is back to arrays. So if we remember, when you're accessing an array, you specify a value between square braces. That's called the subscript. C++ does not make sure it's a valid subscript. Other languages do. So, if you have an array that looks like this, your memory looks like this. Each one of these being a 4-byte chunk of data. So if I say print out nums subscript 0, it goes there, gets that 1 out, does something with it. So that's a 1. If I say num subscript 9, well, that's 0, 1, 2, 3, 4, 5, uh-oh, 6, 7, 8, 9. Only this much memory was allocated for that array. But of course, in the computer, there's a lot more memory. It's just reading past the end of our array, whatever happened to be stored out there. It might be part of a string, like the name Fred, right? The ASCII values for Fred or something like that. And whatever that is going to be what happens when we print nums subscript 9. That's invalid data. You have no idea what it's going to print. If you compile for debug mode in Visual Studio, it'll fill it with a very noticeable message, a very noticeable value. But if you compile it, in release mode, you have absolutely no idea what data is stored out there. And if you're doing development in another environment other than Windows, you have no idea what variable is going to be, what data is going to be stored out in that byte. Or if you say nums -1 or nums, -1 actually works in Python. It loops back around to the end of the string. But what it does here is we have 4 more bytes here. We have no idea what's in that stuff. But it goes ahead and would access it. We could write to it. We could write to this one. We would be corrupting memory. The program might not crash. The program might crash. The operating system might detect that we're writing out of bounds. The operating system might not. If you're running it in the Microsoft debugger, it'll probably catch that the stack was corrupted, that we wrote past the end of data. But there's no guarantee. So we're supposed to take great care to make sure that we don't write past the end of the array or read from before the beginning of it. So negative subscripts are a problem. Subscripts that go past the length of the array are a problem. If the length of this array is 1, 2, 3, 4, 5, 6, the length of it is 6, we can only access elements 0 through 5 because that's 6 values, right? 0, 1, 2, 3, 4, 5, right? All 6 elements. So typically you say you can access 0 through n-1, where n is the length of the array. Just remember you can't go all the way out to element 6 if it's declared a 6, because that would actually be 1 past the end of the array, because you're starting at 0. 0, 1, 2, 3, 4, 5. That's all you can get if it's an array of length 6. So here we declare an array of size 3. We try to store 5 numbers in it with a for loop. It goes ahead and does that. It might blow up, it might not. It might crash, it might not. The Microsoft debugger might capture it, it might not. I don't know what it'd do on the Mac. You type it in to find out. You're supposed to make sure you're not writing past the end of the file in this language. Java will display an error. Well, it'll generate an exception. It will blow up in your face. And blowing up in your face is better than a silent error that might or might not be corrupting memory. So what is the code doing? Just like I showed you. Our array is 3 elements long, but we have bytes before and bytes after it. So when we tried to write out 5 elements to it, we went straight past the end of the array, and whatever other data, whatever other variables, or whatever was stored out here is getting corrupted. People have used that kind of idea to do attacks on machines. The first great internet worm used a bug in the SendMail program on specific operating systems. Don't remember if it was Unix or not, probably a flavor of Unix. And then it wrote past the end of an array. If you passed in too much data into SendMail, you passed in a name that was too long or an address that was too long. And guy was able to figure out that if he wrote a certain number of bytes in a certain length in a certain field when he was calling the SendMail program, then he could install, he could take control of that computer. And there's a big lecture about the SIN mail worm that I could get into. It was pretty neat. It brought down a whole bunch of computers back in the very infancy of the internet in the mid-'80s. So you have to be careful not to use invalid subscripts. And he didn't mean for it to break it, bring the internet down, or kill all those machines. He just wanted to map the size of the internet. And so they were all supposed to just, report back in, send an email back to them, and then quit running. But they didn't quit running. And they kept infecting each other, over and over and over until you had a whole bunch of processes running on each machine, so many processes that would crash the machine. So if you write past the end of the array or try to read or write past the beginning of it, you can crash it, it can lock up the computer, it can cause elusive bugs, corrupt memory, corrupt variables. An off by one error. That's when you use array subscripts that are off by one. Like this. Say you're writing a game and you're supposed to be counting people's scores, right? You're writing a bowling game or whatever, and I don't remember how many racks there are, 10, there are 9 innings, right? You're writing a baseball game. And so you write a loop that looks like this. For int I is equal to 1, I standing for inning, I is less than or equal to 9, I plus plus, and then you declare an array, home team. The home team gets, 9 values. And so for each inning, something happens. We ask the user for the value. And I really ought to make y'all type this in because I know that when I'm just typing in code and I'm not making you type in code, you're not watching me and it hurts my feelings. Anyway, see out what did the home team earn? We're going to read that into a variable, and then we're going to store that into our array. Home subscript, I is equal to the number. But there's a problem here. Anybody see the problem? What is our first subscript? According to this for loop. And what should the first subscript be?
0.
It ought to be 0, right? So this is going to start with 1, and it's going to go past the end of the array. That's called an off by 1 error. And sometimes it can be a little bit more subtle than that, but that demonstrates it. So what do you have to do? You could put a -1 there. You could change it so that it counted from 0 up to 8, and then you wouldn't have to subtract the -1 here. Array initialization. You can initialize an array between curly braces. If you do that, you don't have to specify a size. It's nice to have the size though, right? We've already talked about how C++ cannot necessarily determine the size of the array, so if you declare a constant that has a size in it, then you can pass that constant around. It's very useful. But we don't have to. We could do that. And there we go. We still have an array with those values in it. The values are stored in the array in the order in which they appear in the list. The initialization list cannot exceed the array size, so if we set size equal to 4, but we try to stuff 5 values in it, I don't know if that's a compilation error or a runtime error. I bet it's a runtime error. However, you can put fewer elements in. If you do this, it'll write 79 to the first element in the array, and then it'll pad it out with zeros to the end. So we'd have a 79 followed by 4 0 elements if we did that. So you can put too few in, but you can't put too many. That's a fast way of initializing your array to 0. You do that, it sets the first element to 0, and then the rest of them default to 0, and boom, you're done. You've zeroed out your memory. Otherwise, you have to write a for loop or something to do that. So here, this code demonstrates, 30 days, that's September, April, June, whatever. January is 31 days, February is 28, most of the time. March is 31, and so on. And so we could say month subscript count plus 1 has days, count days. Let's go ahead and play with this, but let's also have an array of month names so that we can say January has 31 days, February has 28, and so on. So I'm going to fire Visual Studio so that I can do that. this, y'all, to the boilerplate. You Mac users already have the boilerplate as soon as you make your project. You show-offs.
Which lecture is this?
Elemental PQ. Alrighty. Alright. I would just copy and paste, but if y'all don't have the PowerPoint, you're not going to be able to copy and paste, so I kind of have to memorize these numbers or something like that, or have them both on the screen at the same time. Alright. So int or const int num underscore months equals 12. That's how many months there are. Now we're going to create two arrays, one with the number of days in each month and the other with the month names. So int days, real creative name, subscript num underscore months in subscript equals, and I need to fill in that little list of values. 31, 28, 31, 30. How about we shorten our example to only 4 months, right? And now I'm going to create an array of strings. Same length, it's just going to have January, February, March, and April in it. So string months or month names, string months subscript num underscore months equals curly braces Jan end quote parenthesis curly brace quote Jan end quote comma Feb end quote comma Mart end quote comma APR. Okay, now I'm going to at first do it the dumb way, and then I'll probably write a for loop to do it. But C out, arrow, arrow, months, subscript 0, arrow, arrow, quote, has, space, end quote, arrow, arrow, days, subscript 0, arrow, arrow, quote, space, days, period, backslash n. Then I'm going to copy and paste that so that I'm printing out 1, 2, and 3. And this is the dumb way. Obviously, it should be a loop. So 1, 1, 2, 2, 3, and 3. All right, so January is 31 days, Feb is 28, March is 31, April is 30. And if we had wanted to, we could have filled it out with all 12 months, right? But like I said, this is kind of moronic. We have this code repeated 4 times. We should actually write a loop to do that. in which case I would have a counter that starts at 0 and goes up to less than num months. Something like this. For, parentheses, int I equals 0, semicolon. I is less than cap, all caps, num underscore months, semicolon, I plus plus. I'm going to copy one of these lines here, just to speed things up. So I just highlighted one of my cout statements. I'm going to put that inside curly braces inside the for loop, and I'm going to change the number to the variable I. All right. And it does the same thing, so I'm getting double output right. So I should probably comment out this stuff and just leave the for loop, because that's the correct way to do it. Anybody getting syntax? We're going to veer back to an earlier topic, which is the idea of file input, file output. What are we going to do? We're going to write this data out to a file. So she's going to be another for loop, but we have to create a file handle. So it needs to be an OF stream. Write this to a file. We need an OF stream. If we were going to read from the file, we would need an IF stream. So I need to scroll back up to the top and do # include OF stream. Actually, since I have F stream there, I'm not sure I need OF stream. Yeah, we don't. We don't put an include there. We already have F stream here. And I hope I don't have an error on a quiz or something based on that. Okay, so down here we're going to create our OF stream. I'm just going to call it F out, like cout for console, and then fout.open, and I need a file name to save my stuff to. I'm just going to call it months.txt. And I'm going to write out the names of the months. So I'm going to need a for loop.
Yeah, you just copy and paste it over.
I could. I'm kind of veering from what I just said. We could go ahead and copy this. Let's do that. Let's steal this code, but we're going to wind up changing it just a little bit. I should make sure that it opens successfully, though. So if not fout, we're going to write an error message and exit. No, we're not going to exit. Cout could not open file. Now we should have stored this in a file name variable so that we could echo that back out. Else, let's do some good stuff. Tell you what, let's just go ahead and write that out exactly like that. No changes, no nothing. Except, instead of sending it to cout, we need to do fout. So, fout. And then once we're done with our for loop, we're going to close the file. fout.close. I didn't write a message saying that I'd written the file. I have no idea if it's working or not. So if I get here, I'm going to display a message saying file written. Cout arrow arrow file written. And again, I should have stored that variable, that file name in a variable, so that I could use it for these kinds of messages. And so this next statement is going to work for the PC users. It's not going to work for the Mac users. I don't know what file, what application you would have to call in order to get this to work. Apologize for that. We're going to call system, parentheses, quote, months.txt. What that will do is it will launch Notepad. Yeah, Mac users try that too. I'm curious as to whether that launches the editor or not. And there we go. There's our output saved as a file. That is useful information. Let me come look.
Did you change the for loop?
Okay. What if we wanted to use what we had just written as input for another application? And you'll remember the one we did where we wrote out the data for a rectangle and then we read it back in. Let's write out those days in a file, in another file. Just the days, just the numbers, so that we can read them back in. I kind of feel like even sticking this code in its own function. So I'm going to do that. I'm going to scroll all the way up to the top where it says int main. And we're going to write a function called, no we're not, I'm going to stick this in main. Sorry for waffling on it. Down here, we have our days directory. We have a variable called numDays. We want to save, not directory, a days array. We have a constant named numDays. We want to save the contents of the days array to a file called days.txt. This time we're going to do it right. We're going to go ahead and create a file name variable called days.txt. So string file name is equal to quote days.txt, end quote. Let's create another output file stream. So it's going to be OF stream. I could just reuse the one that we had, but I'm not. OF stream out file equals open parentheses file name. That's wrong. I did that wrong. OF stream out file semicolon. Sorry, slipped into Python there. And then out file dot open quote, not quote, parentheses file name. We have to validate that it worked. So if parentheses exclamation point, if not out file, we're going to display an error message. So curly brace, and then on the next line, cout arrow arrow could not open space end quote arrow arrow file name arrow arrow endl. Else alright, we have that data. Let's write those four values out. For parentheses int I is equal to 0, I is less than num underscore days, I plus plus. Now what's our output variable called now? This one's not f out. Num days is being underlined. What did I actually call my variable?
Num months.
num months. Yeah, okay. Num underscore months. All right. And then so, not f out, what's our new file variable?
Out file.
Out file, arrow, arrow, days, subscript I. And do we want to put each one on its own line? Yeah, why not? So, arrow, arrow, EMDL. And then out file dot close. And let's print a message saying that we wrote it out. So cout, arrow, arrow, file name, arrow, arrow, space, saved, \n. And I'm going to launch Notepad again. For the PC users only. System, parentheses, quote, no quote, sorry, system parentheses, file name. Yeah, that's not working. Alrighty. So, system file name dot C underscore str in parentheses, convert it to an array of characters. C string. Sorry, I didn't mean to be so arcane, but we have seen a slide or two based on that idea. Some functions will not take strings, and the system function is so old it's one of them. So we have to extract from our string class the primitive character array underneath it, and that's what that does. All right, there they are. There's my days and my months. Now that I'm pretty sure those work, I'm going to comment out those system calls. I do need to find out how to make that work on the Macs. Be convenient. Okay.
What does that do? The system?
Well, system does work, but I don't know what app and what path to pass it in order to get it to work.
What does it do? I don't.
Oh, system calls the underlying operating system and tells it to do something. So you can launch applications. You can do anything that you can do in the terminal.
Okay.
So any command that you can do in the terminal, you can also do with a system function. All right, let's write one more chunk of code that's going to read that file. Do something with it, like store it in a new array. So we need a new array to hold that data. Now, by all rights, it ought to be an array of ints, but it doesn't have to be because, you know, when we read them in, an int can be converted to an array of doubles just as easily. So let's make an array of doubles. I'm going to call it d-days for doubles. And it needs to be the correct length. So inside d-days subscript num underscore months, I've declared my array now, and now I need to use an if string to read all that stuff.
I have a quick question.
Yeah.
Where is your system pause and return zero statements? Did they get pushed way down somewhere? Yeah, okay.
Yeah, my system pause and everything is down, way down here at the
I
bottom.
was afraid I was putting my stuff on the wrong side.
Okay, and that reminds me that I'm putting this in the wrong spot. If you type that where I did, cut it and put it right above system pause. File name is equal to days.txt. Yeah, that's what it was equal to before, but I'm going to do that again, just so it's right next to the code that's going to use it. Now let's make an if stream. If stream in file. In file.open parentheses file name. Now this is the code that's more likely to fail than the opening to the right. I mean, when you open for writing, 99% of the time it's going to work unless the user has specified a drive that doesn't exist or the hard drive is filled up. And do hard drives fill up very often anymore. Not really, but anyways. Okay. We still want to, but for reads, it's quite common that the user specifies a file name that doesn't exist. We certainly have to check to make sure this works. So if not, if exclamation point in file, we're going to print out our error message. Cout, error, error, quote, error could not open, space, end quote, error, error, file name, error, error, quote, space, for reading, \n, end quote, semicolon. Else, we're going to do some good stuff. We're going to use a for loop to read in our data. There are other ways to do this, but it involves the possibility that we're going to hit the end of the file, or that we would read past the end of the array. I'm going to do this in the way that I'm thinking, which is just use another for loop, and instead of using error, error to read out of the file, we're going to use error of the other arrows, the stream insertion operator, to read from the file. So for int I equals 0, I is less than num underscore months, I plus plus, and we're going to fill up our D days array with values. So in file, greater than, D days subscript I. After our for loop, we want to close the file, and we better print our array out just to make sure that it worked. So after that for int I is equal to 0, I less than num months, I plus plus, in file, arrow, arrow, D days subscript I, in file.close. And let's just print out our array. One more for loop, but let's use a range-based for loop because the syntax is easier. For, parentheses, double D colon D days, into parentheses, Cout, arrow, arrow, D, followed by a space. So Cout, arrow, arrow, D, arrow, arrow, quote, space, quote, semicolon. And after we're done printing it out, let's print out an ENDL. So Cout, error, error, ENDL. That's just to make sure that we have some data. All right, and there's our data. 31, 28, 31, 30. That's what we just read from the file. And I guess I'd like to add a little message saying that we finished reading from the file. So after infile.close, Cout, data read from, space, end quote, error, arrow, file name, error, arrow, ENDL. All right. And then we could do stuff with that data, right? We could calculate averages or whatever. All right, the reason I wanted to hit the idea of file I/O again, well, for one thing, it's just awfully important, right? And the others, I have an assignment coming that has you do essentially this. Save some data to a file, and then read some data from the file. Anybody need typo correction? How y'all doing? You know what I'd really like to do is to find code that would ask the Mac operating system to tell me the current username and build a path to the current user directory. And that way you'd be able to go, okay, you know, I'm going to build my file name real easily based on that. Even better would be to pop up a file save directory, but okay, that's a little bit beyond what we're doing here. So you can initialize an array with fewer initializer values. Right here's int number 7, but we only pass in 4 numbers, 1, 2, 4, 8, and so the rest of them are filled with zeros. Calls them uninitialized elements. That's not actually true. They are initialized, they're just initialized with zeros. You don't even have to specify a length if you're going to depend upon the initialization list. Here we initialize it with 4 values, so we left that value out. The only risk of that is then you don't have a constant floating around telling you how many items are in the array. And yes, you can calculate the length of the array in some contexts, but not others. If we wanted to, we could figure out the length of the D-days array like this. Int len is equal, and you use size of. Size of D-days into parentheses divided by a size of a double, like because it's an array of doubles. Now we know how many elements are in that array. However, the size of trick only works if you're in the same context, if you're inside the same function where the array is allocated. If you pass the array to a function, it's not going to work. Now I say that. If you pass it in as a reference, maybe it'll work. I'm not sure about that. Guess we could find out. I want to test that out. I know we have lectured about references. I'm pretty sure we have. Have we? I think I'm getting this confused with C#.
Yeah, just do it anyways.
So what are references? It's normally, when you have a function, it's getting a copy of the data. And what do I mean by that? If you write a function that looks like this and don't, and then you call foo, right? This variable and this number are not the same memory address. The value 10 is copied into X. Just like if you do this, int y is equal to 32, and then you pass in y here as your argument. X is not the same thing as y. X just happens to contain a value of what was stored in y. And that can be important. If we went into our code and we typed in this, y is equal to 300 there, and we tried to print out the value y once we got here, like that, we might expect that this would print out 300. Oops, sorry. We might expect that after we called foo and passed in y, and we get here and that parameter is set to 300, that y would have been set to 300. It's not. It was passed by value. It's passed by copy. We passed a copy of the data in, just like I hand you a photocopy, you know. You can do whatever you want to with that photocopy. You can write all over it. You can crumple it up and throw it away. It doesn't matter. I still have my original value. So that does not change it. And the reason it doesn't change it is not because of names. It doesn't matter whether that's called y and y. It doesn't change its behavior down here, because this is completely different than that. This is a variable that accepts a value, and this is a variable that's passed to it, and the names don't matter. We could call this Fred, right? Variable names only matter to humans, not to the computer. So that's passing by copy. That's passed by value. You can, however, also pass by reference. Reference means you are giving it the original variable. It's not passing in a copy of the variable, it's passing in a reference to the variable. So I'm not giving you a copy of the piece of paper, I'm actually handing you the piece of paper, and you can do whatever you want to. You can write on it, and then when I get it back, when the function is done, it's been written on. So let's do that. Int, I'm going to change these to void. just because I'm not actually returning a value, right? Nope, because then I have a problem down here. Okay. Int return x, right? And then int bar takes a variable, but it's going to be a reference variable. The way you declare a reference in this language and not in C#, and you don't even have these in Java, is that. The ampersand means this is a reference to the original variable. So if I change its value to something, x is equal to 1,000, and then I print it out later, it will print out 1,000. So if I do this bar, passing in y, and then I print out y again, it's going to set it equal to 1,000. The first time it's just going to equal 32 because that's what it originally was, and there was no way for this function to change its value because it was not being passed by reference. It did not have a reference to it. It only had a copy of the data. This one actually gets the actual variable y, and so if it changes it, it changes it. Now notice it still has a different name. But it doesn't matter. It's like if you create shortcuts on your desktop, right? You know, you love Word so much that you put a shortcut to Word on your desktop. Well, that shortcut can have a different name. You can go and edit the name. But it's still the same thing, right? You launch the shortcut, the actual Word application goes. Same thing here. Even though we're passing in a variable named y here and the parameter is called x, at the point we get in here, x and y are the exact same thing. They're pointing to the same area in memory. So any changes here are reflected out here. So when I run it, I'm expecting it to say 32 from the first one because foo was unsuccessful in changing the value of that parameter. And then it should print 1,000 because bar was capable of doing so. Or not. Bar must return a value. Well, true enough. How do I dock things?
Do you need to have return in bar?
Yeah, I need to put a return there. I'm trying to remember how to dock this down to at the bottom of the screen. Okay. By the way, if your code does not compile, what I need you to do is to send me a picture of the output window. Like I run it, there were build errors. By the way, if you ever get this message, would you like to run the last successful build? Never say yes. Always click no. And do not check this, do not show this dialog again because this is very useful information. Okay, but anyways, in order to help you figure out what's going on and for you to help yourself, you need to get the output window open. It'll show the result of the last build. And this is saying that on this line number, on line number 18, bar must return a value. So you can double click on that error, it'll take you straight to the place where it failed. Okay. And as I boasted, 32, 1,000. Oh, now what I'm questioning is I know that if we wrote a function that accepted an array as a parameter, that the size of will not work. But what if I pass it in as a reference? I'm not even sure I know how to do this, but I'm just going to call it test. I'm going to declare it as void so I don't have to make a return. It's going to be an array, but I'm going to use the ampersand to indicate that I want it to be a reference. Now I'm not even sure if that's going to work. Alright, I'm going off the rails here. Oh well, don't know how to do it. Not going to talk about it any further. For now, let's stick with the idea that if a function needs to know the length of the array, you better pass it in. So if we're going to write some code that's going to print out the array, or sum up the numbers or something. Int sum, or double sum, something like that. I'm going to write sum array, and it's going to take an array of ints, or an array of doubles, or whatever data type we want. But we also need to pass in the size of the array. Otherwise, this function has no idea how many. Now, list comprehension, a for each loop, a range-based loop might work. Let's find out. For double D colon D array. I'm not expecting this to work. Yeah, it already gave me an error. Nope, can't do it that way. All right, for the same reason that you can't call size up. Okay, so I need a total. Double total equals 0. And then for parentheses int I equals 0, I is less than size, I plus plus. Total plus equals D array subscript I. And then let's return that total. Now we could pass our array, if it's an array of doubles, to that function. And it would calculate the total and return it. It would not work if I had not passed in the size. It would not know where to stop. And you could try tricks. You could say, okay, if I make the last element a -1, I'm going to program this function so that if it ever hits an element equal to -1, it stops. You can kind of try to be tricky. But the best way to do is to keep track of the length of the array and then just pass that in. Now to test this out, I should scroll down to the bottom and call sum array with that D2 array, or whatever I called it, days 2 or D days. I should pass that in there to test it out. So I think I'll do that. But for those of y'all who may have wanted to type this and who may not have gotten it done yet, I'm going to carry it with me down here to the very bottom. All right. And so here I'm going to call sum array. I just move the function. You don't have to move it yourself. So int sum, or double sum, is equal to sum array. And I'm going to pass in my D days array and the size of it, which could be num underscore months, or it could be that size that I just calculated. And I can print it out, make sure it works. See out arrow, arrow. Sum is space end quote arrow arrow sum arrow arrow India. And there were build errors. Oh, I need to move my sum array code back up to the top, or I need to add a reference to it, not a reference. What is it called when you copy the function header and put it up at the top, but with a semicolon at the end of it?
Prototype.
Prototype. I need a prototype up at the top. You don't have to do that unless you added your sum array function to the bottom like I just did. All right, we are about out of time. We want to make sure this works. We worked so hard at it. Okay, yeah, and the sum is 120. I believe that. You ever wondered why October is not the 8th month? November is not the 9th month, and December is not the 10th month. That's the way it was originally, and then a couple of emperors inserted their own months in there.
Yes.
July and August, right? Julius and Augustus.
Very lucky for them.
Yeah. Okay. I think we're done. Let's let me go show you the homework assignment. Create drop boxes. Maybe not in that order. So it'd be Dropbox Q. All right, refresh. You'll see Dropbox for lecture queue. Let me explain the homework. Homework, arrays and file I/O. All right, so your program needs to do the following. It's going to create an array and a file based on that array, and then it's going to read from the file into a new array and use that data. Specifically, have your program create an array of 7 doubles and then populate the array with random numbers between 1 and 100. Why only 7? I don't know. It could be 1,000 numbers. It could be 10,000 numbers. It could be 100,000 numbers. Let's increase that. All right, an array of 10,000 doubles. And then populate the array with random numbers between 1 and 100. Hopefully you remember how to do that. If not, you can Google it up, or you can look at your prior programs that needed random numbers. So the random values can be ints, but I do want you to store them in an array of doubles. Why didn't I just store them in an array of ints? I don't know. And then store the arrays into the text from the array into a text file using OFStream. Remember to close the file afterwards. It's very similar to some of our code. And then part B, read from the file into a new array. The program will then open the file for reading as an iStream and read from that file into the new array. The program should print that array. Okay, so that's why it shouldn't be 10,000 elements long, right? Because I don't want to see it print 10,000 things. How about 100 doubles? And then the program should calculate the average and the standard deviation of the values. All right, standard deviation. Ooh, we're getting into statistics. Am I going to explain what standard deviation is? Nah. Am I going to make you write your own standard deviation function? Nah. Second page, I give you one. Now, here's a function for calculating the standard deviation. If you've never taken statistics or don't know what it is and want to read about it, feel free. Otherwise, just paste this in. Trust in the force. Assume that it works. So here's our function. You pass in an array and you pass in the array length, just like our sum array function did. It needed an array and it needed a size, a length of the array. And then it does some math, does some good braining, and then it returns the value of that. All right, so I'll upload that. That's the homework. Does that make sense, guys? Real similar to what we did, almost too similar. That's all right.